On to axis. The axis is the direction that the heart depolarizes in, and we look at it in the frontal plane, so that's just the limb leads. So we're not talking about the V leads when we talk about axis. We're just talking about leads 1, 2, 3, AVR, AVL, and AVF. So the heart generally depolarizes in this direction, the ventricles do. So that would be a normal axis. This is also a normal axis. So is this. And this is a normal axis in our facility, but it's close to abnormal. And then this is also normal, but that's close. Axes in this direction and this direction are abnormal. And that can give you some clues about what's wrong with the heart or that there's a problem. For example, if the left side of the heart is very thick and muscular because of high blood pressure, then the axis will point more towards that, and you can actually get an axis like this with left ventricular hypertrophy. If there's a heart attack and a big part of the heart isn't working, so say this is all dead, then the axis points away from that because this stuff isn't depolarizing, so you get an axis more like this, which is also abnormal. We could talk a long time about axis, but I want to keep it simple and clinical. I find it useful to memorize this over here, the directions for each of the different limb leads. So lead 1, 0 degrees. AVL, minus 30. This would be an example of minus 90. There's no lead matching that. AVR is minus 150. Over here, lead 3, 120. So that's defined in this direction because it's positive if you go all the way over here, and this would be minus 180 or plus 180. Could be either one. And then in this direction, the numbers are negative. And that's all by definition. Anyway, AVF is a 90-degree axis, and lead 2 is a 60-degree axis. Of these, the three most important ones are lead 1, lead AVF, and lead 2, because you can use those basically to give you an idea of the ballpark axis value. An axis isn't something that's super quantified. For example, you're not looking for an axis number like 92.4 degrees. It's a ballpark type thing, and you want to be plus minus more or less 15 degrees. So I use two different methods to determine the axis. And let's look at the first one here. I call it the thumbs method. And you apply the thumbs to leads 1 and AVF. So if lead 1, when you're looking at the axis, lead 1, if that's positive, and this is positive here, because the up is a lot more than the down. This is how you determine the overall net vector, if it's positive or negative in a given lead. So if the up is more than the down, as it is here, then this is positive. If the down is more than the up, then that's negative. And it doesn't matter which comes first, the positive or negative part. So if it looks like this, that's negative. And if it looks like this, then that's positive. Anyway, you look at lead 1, and if it's positive, that's a thumbs up. So up, thumbs up, positive. And that tells you that on the circle that I showed above, that the axis, if one is positive, then you know the axis is on this side of the circle. Then you look at lead AVF, and you look to see if it's positive, and this one is. So since it's positive, both of these are thumbs up, and that's generally a good thing. That's going to be a normal axis. When lead AVF is positive, this is defined as positive for AVF, 90 degrees. That means you're in the bottom half of the circle. So since both of those things are true, you can go over here, and the intersection of those two is here, and you've got an axis from 0 degrees to 90 degrees, which is normal. At our institution, a normal axis is defined as minus 30 degrees to 100 degrees. But different places have different definitions, and some will define normal as just 0 to 90. Anyway, we use minus 30 to 100.